Alright, so like I said, we've done this before, but we did it according to absolute values. So now we're doing it towards quadratics, which is more like what we'll do most of the year. So algebraically, quadratics, we have y equals x squared. Make sure you guys have a calculator too. Alright, so numerically, if I plug in x, I'm going to just make up some numbers for the table. I'm going to use -2, -1, 0, 1, and 2. Those are completely made up. They're just easy for me to plot. Let's say I want to plug this in. You don't have to write this. I don't need to know if you have that much space. But you have -2 squared. On your test, a lot of you did not put whatever you plugged in parentheses. -2 squared with parentheses is equal to 4. Without parentheses, it's -4. So that could change your whole answer. So we have 4 for this. What's the square root of -1? +1. What about 0? What about 1? What did you say? +1, right? And then 2? 2 squared is just 4. I just plug those in. Let's see. Alright, let's plot those points. Those are all my points. Alright, so we're going to connect them. Okay, that's pretty bad. And we're basically trying to make a U for my parabola. This is called a parabola. It may look like a U or an upside down U. If you make it like with a point, that's the absolute value. Very, very different. So be careful. Alright, vertex form we've seen before. This is y equals a times x minus h squared plus k. We've seen that, but we've seen it with absolute value bars. Standard form, you've also seen, is y equals ax squared plus bx plus c. It's just putting things in order from your highest exponent down to your number. In intercept form, this y equals x minus p, x minus q. I don't know why they picked those letters, but they did. Some mathematician. Alright, so for the second part of sneeze. For the second part of your notes, I'm going to go back and forth because mine are a little different. Alright, your domain. How far left and right will this graph always go? It looks like it's here, but if we kept extending, it goes on and on. Go ahead, Sonia.
Infinity.
Yep, it goes from negative infinity to positive infinity. Yep.
And if it's going
I told you it doesn't go away.
It's the same.
If it what? If it's going down, our domain is looking from left to right. Always going to be all real numbers.
So it's not going to be both negatives?
No.
Okay.
No. If we look at this from our range, I start from the bottom. Where does my graph start?
Sure.
And I go up towards? Yep. So my 0 is going to be with a bracket. Your range for this unit will be the only thing that can have brackets. Nothing else. Alright, is it continuous?
Yes.
Yes, I can go from left side to my right side without picking up my pencil. So it is continuous. There are no holes in my graph.
What do you mean by holes?
Like it's not like I have a graph that looks like this and then it keeps going. It's like a circle there.
Oh,
Okay, so that's always going to be yes. Is it 1 to 1? So that means if this is our parabola, 1
Yes.
to 1 means
no,
that if I draw horizontal lines, it only touches one time. Is that true?
no.
No, it touches twice. So it was not 1 to 1.
Yeah, that'd be easy.
Okay, my vertex. Where's my vertex? What's this point?
0, 0.
0, 0. So my axis of symmetry is x is, you have to put that. Your axis of symmetry is always the x value of your vertex. So that's going to be what?
0.
This stuff isn't hard. I think when you guys just do it by yourself, you start overthinking.
Yeah.
Because you always know like what I'm saying. You just get confused on your own. Alright, increasing and decreasing. If I draw a line, you guys can draw a dotted line. So I'm drawing a dotted line between where it changes directions. Alright, so it changes directions at 0. All the way to the left is negative infinity. All the way to the right is positive infinity. I only need these numbers for my increasing and decreasing. So from left to right, are we increasing or decreasing? We decrease and then we increase. Imagine you're on a roller coaster. Ask yourself, am I going up or down? Alright, so I am increasing from where? 0 to, and I'm decreasing?
Negative infinity.
Yep, those will always be parentheses. Is this constant anywhere? The answer is no, because we're either increasing or decreasing the whole time. Alright, do I have a max or a min?
Both.
Can't have both.
Max is in the perimeter, right?
Do I have a high point on my graph or a low point?
Low.
Low point, so that would be a min. So this is none. My min is also my vertex. Your max and min will always be also your vertex. We'll talk about that later, about how you have to use it.
Wait, it's the same as the vertex?
Yeah, so I'm only gonna have one, right? Max or min. This time we knew it was a minimum, so it's gonna be the same as my vertex. Alright, y-intercept means where does it cross the y-axis? Right there, 0, 0. You guys can write it as a point, or you can write y equals 0. I'm okay with either way. Same for my zeros, which we also call x-intercepts. What are across the x-axis? 0, 0. So you can write x equals 0. Our end behavior are basically I call them my hands. But if you're looking at this, what are my arrows doing? They're both going up. They're going up to positive infinity. For this unit, these will be the same. Will be the exact same. Because they're both going up or they're both going down. Any questions here? Does this stuff ring a bell? I hope. Okay. We all should be able to do well this unit. And I'll make you guys look foldable too. Alright, so this first letter, A, we've also done this before. A tells me my slope. My slope can do two things. It can stretch. What else can it do?
Compress.
Compress. Who remembers how we can tell if it stretches?
It was
Not quite. Let's see, no?
it was that one formula.
Give you want something different. But for stretch, it has to be bigger than 1.
Huh.
This number here has to be bigger than 1 in the stretch. If it's lower than 1, it compresses. Alright, my H tells me how to go horizontally. I have 2 options. I can go left, or I can go right. If I go left, how do I know? Will it be plus or minus?
Plus?
Yes. And I remember that because, remember my plus sign, I see 2 plus signs in the word left. So that's how I remember. And if it goes right, it's a minus sign. I remember because I cross my T with the minus. So if it's plus, you go left. If it's minus, you go right. My last number tells me how to move vertically. I can either go up or I can go down. How do I know if I go up? Positive or negative?
Positive.
And down will be
Negative.
negative. Who remembers if this is a negative in front of our slope? Huh? What do you do if it's a negative? You remember? Think back. Nope. If it's a transformation, what does it tell you to do if it's a negative? Starts with an R or an F.
Reflect.
Yes. You reflect or you flip. If it's a negative, you reflect or you flip. Any questions here? All right. Describe the transformation of the function x squared. All right, so we basically have, this is our origin, this is where we begin, and I'm going to this new vertex. I'm asking myself, how do I get there? For this one, we have 2 transformations. What do we do to get there? Yep. Right, how many? Yeah. And then up to. My vertex here has a point is 5, 2. Their function is going to be y equals right 5. Would that be a minus or a plus?
Plus.
Careful. Minus. And up to would be plus 2. So that's my equation.
Therefore, why is it plus -5 if it's positive?
Because we're going to the right. The right tells us it's a minus.
Oh, okay.
And be sure to start at your center and then go here, because if you do the opposite, your equation will be the opposite.
Okie dokie.
Alright, so now I'm starting here, and I'm going up here to this guy.
Right.
We went right 3. What else did we do? Up 5. Okay, there's one more.
Reflect.
We flip. Good.
Right.
Alright, so, yep. Huh? You see the arrows are going down? So it kind of tells us that we flip.
So it's going to be 3 to 5.
So my vertex is 3, 5, yes. And guys, sometimes I try to imagine a parabola looks like this. We can turn it into like a smiley face to be normal, right? That's positive. Literally positivity. If it's upside down, it's negative. So it would be a negative like if you were flip. My classes last year didn't appreciate that, but 2 years ago they did. Alright, so my function, y equals,
X minus
what
5.
happens to my flip?
No, X.
So minus first, right?
Oh, that
Alright, like the flip, so x what?
minus 3 plus
Yeah.
5.
Perfect.
So when it's split, we just gotta put the minus.
Yes. When it's flipped, all you have to do is put a negative. Guys are doing better than this than you probably thought. Alright, so we have y equals negative x. Y equals negative x top or x plus 4 squared. Did I put squared on this? No. This is what I messed up the first time. Alright, go back to this real quick, guys. So I'm thinking about before we did this with absolute value, but now we have quadratics. I keep forgetting my squared. So put your squared there.
Why?
Because that's what we're doing all x squared.
It says it on the chart.
I know, and that's why I'm recording again, because I forgot to say that in my last class. Sorry.
Oh, you figured it out now.
Kind of like plus and minus, but we always forget to do that too. Miss 10. What?
How many subscribers do you have?
Huh?
How many subscribers do you have?
I don't know. How do we even check that?
Yeah.
Right when you go on the page, it'll say subscribers.
Oh no, I'll look it up after this. I always just like upload the video and then click out.
32 watch.
I probably have like 5.
Yo, I'm about to go to like.
Or if you're lucky, even one.
I'm about to
I know. I don't know who would subscribe.
to get that.
Alright, so we can figure out our vertex from this. Is opposite my first number. So negative 4. My second number stays the same. So negative 4, 2. Alright, so this is back to what we did in the beginning. Grab your calculators. I'll grab mine. So what we're doing is we are putting things into y equals so we can get a table. So first, let's graph this. Negative parentheses x plus 4 squared plus 2.
Graph.
Yeah, we can graph it to see what it should look like. All right, cool. We're gonna graph it. We're gonna hit second graph to get our table.
It says error, invalid dim.
You gotta restart your calculator. Hit second, plus sign, 712.
So we would put the numbers that
To reset your calculator, 7.
Wait. Did you get negative 2, negative 1, 0, 1, 2, negative 2, negative 7, negative 42?
Are you reading off the?
No, it barely works. I just press
Okay.
second and then minus 1.
Okay, so to fill in my chart, are you good?
No.
Just reset it. Hit second,
Second,
plus sign,
plus sign.
7, 1, 2. Did that reset it? All right. Yeah, good. Now go back to your y equals and type in your.
That's how it works.
Yeah.
You have to type it in the same as the.
Mhm. Yeah. Did you forget your parentheses?
No. That's the.
What is that?
You just hit second.
All right. So if you type this in, I have negative 5, 1, and then negative 6, 2.
I'm putting a class in your room.
Okay.
Mr. Hagen's class, or it smells too bad. There's too much less in here. So
Okay. Which one?
Josh's.
Oh, okay. Oh, that's why he texted me.
Yeah.
Oh, all right. So negative 3, 1, and then negative 2, 2.
I got negative 4.
For 2.
For 2, both the 2 in the top and the 2 in the bottom. I got negative 2.
Oh, yeah, you're right. Negative 2, and then negative 2. Yeah, I just did it wrong. Alright, so graph those points.
Nice.
Negative 6, 2, negative 5, positive 4, negative 4, 2. Alright, once you have your points, try to make a nice U upside down. That one's good. Alright, so we're kind of done with our table for now. I have 1, 2, 3 transformations. What are they?
I don't know.
Say them in any order. You don't have to say them. Yep, you flip. Alright, what else? Left 4, and then there's one more. Perfect. My vertex, we already put right here in the middle. So we have negative 4, 2. Put in parentheses. Axis of symmetry means x is the same as your x in your vertex. So that is negative 4. Do I have a max or a min?
Max.
You have a max. So your max is the same as your vertex. Yeah. So I always ask myself, do I have a high point on the graph or a low point? This is a high point because the whole rest of the graph is below you. If it was like this, you would have a low point on the graph. So that would be min. That makes sense?
Oh,
So it just depends.
So that would be
If the arrows are going down, it's min.
No, if the arrow's going down, it's max. It's just a high point. If the arrows are going up.
So for example, what if it was like negative 4 and negative 2? Would that be max or min? And it's pointing down.
Negative 4, negative, well, it depends, because that would be right here. So that just depends on if your graph goes up or if it goes down.
And if it goes down?
If it goes down, that would be max.
Oh, okay.
Yeah, I just always ask myself, is it high or low?
so from min we will put none.
Yep. Alright, so this part is kind of new. Your y-intercept is where you cross the y-axis, right? What if we can't see it? Can I see where it crosses the y-axis? No, I have no idea. And that's just because my graph doesn't go up that far. But you can look at your table. So look at your table to where x is 0. Wherever x is 0, that's your y-intercept. They're kind of opposite. What'd you say? Negative 14.
How do you get that?
Because my x,
Oh, on the ground. Oh, yeah, I see.
yeah, you're looking for where x is 0. They're kind of flip-flop, which is a little confusing, but just gotta memorize it.
So y is always 0 in some other number?
Yes. For your x-intercept, you can do the same thing if you want. You can look and see where y is 0 and put that in. But if you don't see 0 for y, that means that it's a decimal. Okay? I'm not going to be too picky on this. You guys can just estimate. My x-intercept, wherever it crosses the x-axis, looks like negative 5.5 and negative 2.5. I'm okay if you guys put them like that or as a coordinate. You can either put x equals or you can put the coordinates.
Wait,
Same for this one, like for your... Alright, so for number, or for y-intercept. Your y-intercept, you can have two answers. You can write it like this, or you can write y equals negative 14, right? So for your x-intercept,
how do you get your x-intercept?
you look to see where it crosses the x-axis. They're both the same. Your y-intercept, you're looking to see where it crosses the y-axis, but it's not there in my drawing, so I just did the second way, which is where y-x is 0. Your x-intercept, you're seeing where does it cross the x-axis.
So I'll be ready.
So you can write it as negative 5.50, negative 2.50 if you want, Or you can write it like I did, and I just put them all together. X equals negative 5.5, negative 2.5. Does that make sense?
Yeah.
I know it gets tricky because you have to try to find it, but just imagine where does it cross either the y-axis or the x-axis. If that doesn't work, go to your table. Your domain will always be the same for these. Negative infinity to positive infinity. My range, I start from the bottom, right? So I'm starting from negative infinity up to positive 2. So I'm going from negative infinity to positive 2. Your range for this unit will always be the one that gets a bracket. Nothing else will get a bracket. So just do it with your pencil. Start from the bottom, look at your y-axis. All right, increasing and decreasing. I'm drawing a dotted line where I change directions, which is about there. So, all the way to the left is negative infinity. All the way to the right is positive infinity. I'm changing direction at negative 4, according to my x-axis. Well, there's to be both. So if you look at this from left to right, are we going up or are we going down?
Down. Oh wait, oh,
We're going up, right? So this is the increase. And then from here to here, we're decreasing. Alright, so I'm increasing. I'm only looking at these numbers that I highlighted. I'm increasing from negative infinity to 4. Oh, negative 4.
And then decreasing.
I'm decreasing from negative 4 to infinity. Eventually, this stuff gets easier. I know they're all like new words and they all kind of like play on each other, but it does get easier. All right, is my graph going up or is it going down?
Down.
Down towards negative infinity. All good on that one?
What if it was going up? It would be positive infinity and positive infinity?
Yep, they'll always be the same because they're both going the same direction.
Okay.
All right, so let's take a look at this guy. My vertex, I can tell from here. What's the opposite of negative 4? And this number stays the same, so that's negative 2. That's your vertex. So there's some things I can fill in before I even look at my graph. What else can I fill in?
Isn't it negative 4?
It's opposite the first number.
Oh.
Opposite the first, keep the second. My axis of symmetry will be what? 4. I don't know if I'm going to have a max or min yet, so we can wait. My domain is going to be negative infinity to positive infinity. My transformation, I can tell from my equation. I have 3 of them. What's that 1/3 tell me to do? Stretch or compress? Compress. It's smaller than 1, so think small. What about my negative 4? Left or right? Right 4. And then my negative 2?
Down 2.
Down 2. I want you guys to type this in and get some points in your graph.
Wait, why is it compressed? I thought compressed was if the H was smaller than 4.
Nope, compressed is like our first number. So look at that 1/3. We're asking ourselves, is it bigger or smaller than 1?
Smaller.
So it's smaller, so we compress. If it was bigger than 1, you would stretch.
They both got a bunch of decimals.
All right, they're both going up.
I'm gonna come.
Alright, what's my range? I start from the bottom. Where's my graph start? Look at your y's. No, look at your y's. -2. And it goes up to positive infinity. Infinities always have parentheses. Alright, so for your y-intercept, you're looking for where it crosses the y-axis. Well, this drawing may or may not be right. I don't know. So let's look at our calculator. Let me type this in really quick.
With the y-intercept, so it would be within that.
And don't even talk, you got me wrong.
Where was the 0 be?
I'll let you know. Alright, so for my y-intercept, I'm going to see where x is 0. What's that point? 3.33. So my y-intercept is 3.33, or you can write 0, 3.33. Either way works for me. My x-intercepts, I'm going to see here. I don't have a 0 for my y column, so that tells me I have a decimal or a fraction. So let's just estimate. Looks like for crossing, I can't even read the graph. Let's get the actual graph. This is what it looks like. Alright,
I
so
felt like at 1/2 and
yeah, 1/2 and
5/2.
1, 2, 3, 4, 5, 6. So my x-intercepts are 1.5 and 6.5. If you guys just round that and just make sure it's within, like if you wrote 10, clearly that's not it. But if you wrote like 5 or 6 or 7, I would give it to you. Any question on that one? All right, last one because we're skipping the fourth one. I'm going to get you guys started on this and then you're going to do it yourself. Then we'll check. Do we see how this equation does not tell me my vertex? It says standard form. The other form was vertex form. I could easily find it.
Oh, yeah.
Now it's in standard form. I don't know what that is. Go to your y equals. Make sure you focus on this part. It's a big part. Alright, so let's type in negative x squared plus 4x plus 4. Alright, and then we're going to graph it, see what it looks like. Type in negative x squared, or you just type in minus sign. Make sure you do negative. Alright, looking at my graph, do I have a max or a min?
Max.
Do we all agree it's a max? And this is that a yes? Okay. Okay, this is a max because I have a high point on the graph. So, I'm going to hit second trace. Which one do you think I need?
second. Where's this trace?
Oh, second trace is under caps. Do I need max? Okay, I need my max. Ronaldo, are you good?
Which trace?
Alright, watch me. Second, and this little guy up here, right beside the graph. You're going to go down to maximum and hit enter. Make sure we're doing this together or you'll get confused. Alright, we're going to put our little blinky guy where we think our maximum is. Are you guys here so far?
Yep.
Ronaldo?
Yeah.
Ryan? You good? You guys good? Alright, my little blinky guy is here. My calculator is asking, should we go left bound? We are going to say yes. So click your left arrow 2 or 3 times and hit enter. Yep. And then we go back to our regular maximum that we think it is. And then we go again 2 or 3 times and I hit enter. because it said right bound. So I went to the left 2 or 3 times, enter. Went to the right, enter. Now it's asking me, should we guess? We want our calculator to guess because it's very smart. We hit enter and it's going to calculate the average and give us a maximum. So they gave us, you may have 1.99999 or you may have 2.00000. Okay? Either way, it rounds up to the number 2. So my maximum is 2.8. If anyone needs help with that, I'll come around once you guys get started. So once we have our maximums 2.8, I go to my table because now I'm good. Now I can figure out what's 2 above and 2 below. So on my table, I look at 2.8, and I know I need, let's see, 1.7 and 0.4, 3.7 and 4.4. Okay, so let's go ahead and graph that. About 3 minutes on that one. My vertex.
2.8.
2.8. Oh wait, I didn't even plot the punch yet.
What?
0.4.
Told ya.
1.7, 2.8.
Told ya.
It doesn't have to be perfect, just try to make it look normal. Axis of symmetry, what is X? Max or min, we said max, so that's also your vertex. We don't have a min. Y-intercept.
Is that -2?
Nope. So we're looking, you can see where it crosses the y-axis, which is 4, or you can look to see where x is 0. So y is 4.
X is 4.
My x-intercept looks like -1, because I'm crossing here. It's somewhere there. It all depends on how you draw it. So if you wrote 4, that'll be right. I'm going to write 4.5 if it looks like it's in between on my drawing. But once again, our drawings may be off a little bit. Domain, negative and the positive. There you go. Don't get that one wrong. It's the same thing for all of them. My range, I start from the bottom. And I'm here. What am I pointing at?
8.
8. So my range is negative infinity to 8 with a bracket.
Wait, so, right, I got that one wrong.
Yeah, you got it.
I didn't get 8, I got 2.
Oh, if you got 2, you look at the x-axis. Look at your y. Think range y's. Increasing and decreasing. This is where I change direction. Alright, so all the way over here it's negative infinity. I keep going towards positive. I change directions at 2.
Oh,
Because remember, for our increasing and decreasing, it's always my x values. Alright, I'm increasing.
-8, negative infinity, and +2.
Yeah, I'm increasing from negative infinity to positive 2. And I'm decreasing from
2 to positive infinity.
decreasing from 2 to positive infinity.
Negative.
My end behavior, my graph is going down.
So negative.
Negative,
Alright,
negative. Any questions so far?
yes, there we go to the 6th level.